Són les dues, oi? Sí? Okay, it's 2 o'clock. We want to start the last turn of parallel sessions talking about metadata. Metadata has been one of the most popular topics in different sessions, but I think in this one we could be really, really interesting because they are more focused on how we can improve this metadata, the content especially, in order to be most useful for the users or citizens or people who is looking for data and information. We have a variety of speakers. We start with Mr. Alejandro Guinea de Salas. He is the managing director at Geogramma, a mapping and GIS company. He is a survey engineer and has a master in geotechnologies with more than 20 years managing and developing cartography, mapping, and GIS projects, and also with an extensive experience in consultancy projects. Just connected with metadata, I want to say that he's working in the metadata group of INSPIRE maintenance and implementation framework, and I think we could take benefits of this presentation. The floor is yours.
Thank you, Dolores. Good afternoon. I feel sorry for you because we are going to speak about metadata and there was not coffee, so good luck. I will try to keep you awake. I'm going to speak really fast because we are going to speak about only one tag of the metadata of a map. I'm a surveyor and I think it's the most important tag, the most important metadata after the title. So, and I think it doesn't have the importance that it should be. Let's go to connect with the Lineage at INSPIRE and then to see what is happening in Europe in some metadata that we studied and then some conclusions. Okay, this is what Lineage means at ISO. Lineage is defined as provenance, sources, and production processes used in producing a resource. It is one of the 30 packages used to define and provide metadata. I'm trying to guess what are you thinking about. Okay, everybody knows that, more or less. But we're still in the same point. Let's go to the European Commission, let's go to the directive, and regards metadata, Lineage means the history of a data set and the life cycle from collection and acquisition. Okay, a bit more, okay, at least we are speaking about data sets, we are closer to know what I was speaking about. But Lineage has a connection with quality as well, which is very important in a map. Okay, information metadata class, this is the schema of ISO, reflects the qualitative aspect of the quality of a data set, but is not compulsory. And it has mainly two classes, the source and process step, and none of them are mandatory, okay? I'm sure some of you disconnected in this point because, okay, it's not mandatory, okay? But don't be happy yet, okay? Just a brief thing. The source has the purpose to offer the source of the data, and process step has the objective of informing about how do you end it with that data, about the life of the data set. Okay, still not compulsory, nobody say about this is mandatory, but now we come to Lineage at INSPIRE. INSPIRE is more than ISO, and in the implementation rules, They say that Lineage is mandatory for datasets and dataset series and is not applicable to services. Okay? So it was too good to be true. I'm sorry. We have to write the Lineage according to INSPIRE and to the implementation rules. If we go more in detail, they say not only that it's mandatory, they say that should contain any quality information required for interoperability and or valuable for use and evaluation of the datasets. And they say that we have to, the metadata set may comprise more than one set of quality information, and so on. I don't want to read everything, but it's important that there shall be one and only one set of quality information scoped to the full resource. Okay, so we have to say something, but only one. And we end in the technical guidelines, and they say that Lineage valued domain is free text, so it's not structured, and it is added a recommendation to use the sub-elements of Lineage as follows. The process step and the source. The process step, as we know, is how do you, what is the transformation process? How do you end it with this data set? And the source is what source data, local, national database used to make the INSPIRE data sets. So it's not that easy anymore. Oof, sorry, I cannot believe it. So it's not that easy now. We have to, it's mandatory, we have to fill a lot of tags, and we have to say something specific. The good thing, not good for interoperability, is that it's free text, so it's easy to write it. Okay, we have some more recommendation about what Lineage should have in a specific themes of INSPIRE. For example, in an elevation, it is suggested to provide information about the coverage of the elevation grid within the tag of the Lineage. About land cover, the observation date shall be provided at the coverage level through metadata within process step information provided in the Lineage. For example, we have we do a map of land cover, and we published the map in 2015, but what information were we using? Because it can be, you will be surprised, I'm sure you know, 4 years before, because it is a work that takes a long time to process. So it should be here. About the hydrography, it is recommended to document the selection of rules decided by each member state for the definition of the objects. It should be here. Cadastral parcels, it is more demanding. The gaps, the structure, the life cycle, the accuracy, so cadastral parcels demands a lot of information. And addresses as well. We have some small or big issue in Spain about addresses because still nobody knows who has to do it. But it's recommended to document the life cycle rules. Let's go to see these fun slides with XML. Okay, but it's the only way to show that there is what we can find now in internet, in the metadata of, I deleted the country, I say some country, I don't want to have problems because of that, but you can see the Lineage tag is just LT. I cannot see say the country, but that seems to be the country. In a DTM, we see, I'm sorry, I don't remember what it means. It's like something about the history, but I don't remember what, but it's nothing to see with the lineage, with which is expected. In this other one, we can see the name of the data provider in the lineage, National Cadastre and Mapping Agency, which is, okay, it's free text, it's filled, but I'm sorry, it's not what we need. It's not what we expect. This is Spain, this I know. I'm sorry, but no, I don't sorry, I'm really proud. It's quite good. We have a lot of information. The only thing that I can say is that they speak about technology as well, and technology, FME, you can see, Oracle Spatial. Okay, it's interesting, but it's not about lineage. It can help to understand what they do, but not that I used FME. I really love FME, but it's not the place to write about the technology. I am more interested in to know what did you do with FME, for example. We have something from UK, I think. We can see that this is pretty good. They speak about accuracy and where is it coming from. So this is another way. But what we would like to do, we are studying many data sets, metadata, sorry, in the workflow of Corda, Copernicus Data Access node, okay? And one of the tasks is to study the metadata that they are available in Europe. And this is our wish list, okay? We would like to have all the tags filled. The first one is the lineage, and we would like to have this. I'm not going to read it, but the description of the source data, okay? In the process step, information about the process transformation, and to finish, in the source, the description of the source dataset used to derive the INSPIRE dataset. It's difficult to work with that because it's free text. It's difficult to do anything about interoperability, but we need it. Any user has to know where the dataset is coming from. So the conclusions is that the objective of offering the genealogy of the data through the lineage is frequently missed. We don't have it. So this is not following the recommendations, is not following the implementation rules. The automatic check systems, the systems to check if the metadata are right, they don't fail because it's free text. You know, you can write whatever you want, but the reality is that the lack of this information leaves the end user orphan. I mean, I cannot use it. I cannot use it for anything real, for anything serious, for any case in court, for any, I mean, there is not good maps or bad maps. There are maps that fit out my needs or not, okay? So this information is crucial to say if the quality of the data is good for the user's need. And that's all. Thank you very much. I want to say that this short presentation is really short, but you cannot see the work that is behind it. So I want to say thank you to Josu, Natalia, Nagore, Olga, and Estivali. Some of them are here because you have to study a lot of lineage to get these short, but I think important conclusions. Thank you very much.
Thanks to you. I think it is better to leave the questions for the end of the session and just to have any of the speakers 15 minutes for itself. Okay, we are moved to the next one. It's Renske van Setten. I don't know if it is well pronounced, but I tried. He's an intern with Dutch Cadastre. He has been working with metadata of that National Geo Register, and he's a student of a Master on Geographical Information Management and Applications. I think it's another point of view, not someone who is using a lot of metadata, but, sorry, producing metadata, but using it and trying to understand what is said behind. The floor is yours, Renske.
Yes, I can't seem to open. Yeah, sorry. Yeah.
No trobem el mouse. No, it's here. It should be here. El mouse no el tenim. Quina és aquesta? No, aquesta és la d'abans. Presentació? Sí, aquesta.
Okay, thanks. Thank you for coming to my presentation. I've studied the metadata of the Dutch National Geo Register, a metadata catalog within the Netherlands, and specifically if the GeoDCAT app is an alternative way to describe metadata. I'll start with introducing some trends in geoinformation and the find, publish, and bind aspects of an STI. The research problem I'm tackling is the lacking cross-domain interoperability of geo-metadata. This research is scoped to the Dutch metadata profile and the GeoDCAT app for describing metadata. My methodology consists of connecting the amount of times a metadata element is implemented to the XSLT mapping of GRC. I'll present my results in bar graphs and show specifically which elements of the Dutch core profile can be mapped to GeoDCAT app and what kind of information loss results from this. At last, I've held interviews to hear the opinions on, from data providers on this information loss. Well, as we all know, geodata is incorporated in daily life. For example, weather forecast, traffic information, route navigation. And the last decades, digitalization has facilitated that we share and distribute geodata on the web. Open data policies has pressured that we use, reuse, and distribute data. And to facilitate this access and sharing, we have a spatial data infrastructure. An SDI is a data infrastructure implementing a framework of geographical data, metadata, users, and tools that are interactively connected in order to use spatial data in an efficient and flexible way. Well, this figure presents the find, publish, and bind aspects. Data is published as datasets and services, and these datasets and services are found through metadata. Well, we know what interoperability is, and standards enable this interoperability. So we're talking about ISO 19119 for describing services and ISO 19115 for describing datasets. INSPIRE is an implementation of an ESDI on European level. Like I said, this research is scoped towards the Dutch National Geo Register. We have a lacking interoperability of geo-metadata. WFS, WMS, and metadata from NGR is currently not found in search engines like Google. So metadata standards are dominated by ISO and INSPIRE metadata technical guidelines. So we question, is there an alternative? And DCAT is a generic metadata profile that covers other data domains. The Dutch core profile is based on ISO 19115, 19119, and the INSPIRE metadata technical guidelines. So the GeoDCAT app. This is an extension of the DCAT app, and for spatial datasets and services, and it provides an DCAT vocabulary for metadata elements out of the ISO and INSPIRE core profile. Interoperability is achieved through the use of the Research Description Framework, RDF, and the reuse of existing RDF vocabularies. So the pro of the GeoDCAT app is that it improves cross-domain interoperability. It enables a conversion to linked data. It's extensible, so metadata elements can be added to the mapping. And it consists, a benefit of the DCAT app is decentralized publishing. So a cons would be that it doesn't provide the structure of ISO and INSPIRE, and there is an information and quality loss as the format of the metadata elements, the contents and the semantics are not conform. So metadata interoperability is achieved by the use of standards and harmonization or transformations between different standards. So how can NGR utilize the GeoDCAT app? This slide presents my research steps. I have data about the metadata implementation of data providers. This is the amount of times a metadata element is implemented inside the metadata records. This is connected to the XSLT mapping from ISO 19139 to the GeoDCAT app. And this gives insights into which metadata elements are frequently implemented and which are seldom implemented. And this also shows if there is a great information loss or a small information loss. And this slide presents the metadata implementation of data providers. On the vertical bar, you can see the amount of metadata elements from the mandatory and conditional elements on the two upper graphs, and the lower graph shows the optional elements. These are 82 elements. The horizontal bar presents the implementation in percentages. So some elements with 100% are implemented in each metadata record. I've separated the metadata that's obtained through the editor and metadata that's obtained through Harvest, because there's a difference. Harvested metadata records are more consistent in their implementation. With this slide, I'll discuss which elements have no mapping to GeoDCAT app. And these are 3 mandatory elements: status, safety restrictions, and the scope quality description. 3 of these elements are seldom used, with the exception of safety restriction and scope quality description, because these 2 elements are frequently implemented by Rijkswaterstaat, RWS, the Environmental Agency for Infrastructure and Environment within the Netherlands. There are also elements that are mandatory if they come from an INSPIRE source. Well, they are conditional, but are mandatory if they are from an INSPIRE source. And some of these elements are frequently implemented and some are seldom implemented to give some insight in what kind of information loss there is. Generally speaking, an important aspect is that only one aspect of data quality can be mapped, and that's conformity with the specification. And optional elements or information from optional elements can be considered loss, except for temporal extent, the geographical identifier, and the spatial representation type. So this bar graphs gives insight in the information loss. Like I've previously mentioned, this is calculated by the amount of by multiplying the metadata element with the amount of times it is implemented by data providers. So it can be concluded that there is a minimal loss of information for mandatory elements, with the exception of the 2 elements used by RWS. For conditional elements, around half of the information is lost, and optional elements should be considered lost, with the exception of the 3 that can be mapped. Well, the opinion of the data providers is discussed around these topics. Data providers are of the opinion that geo metadata should be mixed with other general data domains. They prefer one metadata format to describe their metadata sets, and often they now have to publish their metadata in an open data portal and in NGR, so that's conflicting. But contrary to this, they also state that ISO and INSPIRE is important to meet specific user needs. So they can't really. So they don't want to step away from the ISO and INSPIRE profile, but they also recognize the importance to improve cross interoperability. So it's quite a dilemma. If you see the loss of information through the mapping, they are okay with the loss of information, but then for some kind of users that use specific elements, it's hard to conclude that it is entirely okay. They are for GeoDCAT export within NGR to improve cross interoperability, and they would prefer one metadata format, but they don't want to part with the INSPIRE and ISO metadata regulations. So the discussion. Is the GeoDCAT app an alternative metadata profile? The information loss could be considered okay, but semantics are outside my research scope. So elements don't fit one to one. So it should actually be considered if the format is its format, its contents, and if it's semantically conform to the other profile. From the interviews can be concluded, well, that they well, that's just it's still a bit tricky. But my personal opinion is that a benefit of the GeoDCAT app is decentralized publishing. So if we have decentralized publishing, I think that as one metadata catalog, we can keep the Dutch metadata core profile to attend the user needs of a specific geo community. So the conclusion is that ISO and INSPIRE metadata profiles are unsuited to bridge the interoperability. And we need GeoDCAT to improve the cross interoperability with other data domains. If we want a gradual transition from the Dutch profile to the GeoDCAT app in the future, more research is required for a feasibility study on technical and management level. ISO and INSPIRE metadata recommendations should be adjusted more to describe metadata in the DCAT app. And like I said, more research is required for the loss of information through semantics, the concept, and the format conformity. And I've studied data providers with interviews and their implementation of metadata elements. But it's also important, of course, to include the users of metadata of the Dutch National Geo Register. So, are there any questions or at the end? Thank you for your attention.
Thanks. Okay, the next speaker is Guillem Closa. He is a researcher at CREAF, the Research Center of Ecology and Forestry Applications, and he has been working also in the development of tools to apply to metadata and in different projects to extend the usability of metadata to make more visible, and others to extend the metadata to be used for preservation and of digital information that are not considered nowadays in the standards. Then,
thank you, Dolores. And thank you all for attending this presentation, especially considering there are so interesting presentations not there, so I'm so grateful to you guys. I'm really bad news, so I'm going to talk about lineage information again. I'm sorry, Alejandro and you. I will use provenance information as a synonym of lineage information. But what we will do here is to use the WPS, the OGC standard, to describe geospatial provenance. So, Alejandro presents us and gives us a really nice, he introduced so good what lineage information is, so I don't want to stop too much time to introducing it, but geospatial provenance can be defined as part of the metadata. Normally it's part of the quality metadata that provides information about sources and process used to generate a specific geographical product. So considering if we have a specific data set or layer, if we are speaking in a GIS context, the lineage information are the process used and the sources used to generate that specific data set. So the process, in this case we have two processes, and the process should be defined with the name of the operation or a full description of the operation, a valid URI to the operation, and reference to an engine and to the algorithm. And also the sources should be referenced using a descriptive citation, an element ID, and an element URI or a metadata URI, and also the constant variable or an element that modifies the behavior of the algorithm should be captured as a part of lineage or provenance too. For example, in this case, we have a source which is not actually source, it's a param which it values it's 2. So somehow there are some problems to capture this kind of lineage in some of the actual models. So why provenance or lineage information is important? Because it gives crucial information for data quality assessment, data distribution and geospatial data trustworthiness, and also can help us to reproducibility of the information and replication process. So imagine if we have a complete description of the sources and of the process, And if we know how to point this process and we know how to point these sources, we should be able to reproduce or replicate these workflows. And also it's so good for data usability assessment. It's good to know if this data fits with my use case or fits with the needs of my study. But on the other hand, there are some obstacles for using provenance. So one of the obstacles is the lack of provenance standards which captures the complete workflow. This means that the actual standards that does not describe the provenance information in a way that the users and the producers can realize how provenance useful is. And also there are lack of automatic tools for capturing provenance information, as Alejandro also said. So in this context, what we present a tool to capture geospatial provenance. This tool is developed in the context of Miramon and GIS and remote sensing software. Is based on the combined use of web processing service with the Lineage with the ISO models. Use the WPS describe process documents to capture Lineage, so these documents can be used in a local execution, we mean no web, and captures and represents automatically provenance information. Also allows to edit provenance information manually using the GEM. GEM is the Miramon Metadata and Database Management Manager. And finally, provenance information is stored as a part of quality metadata in a REL format. The REL format is the Miramon native format for metadata stuff. So the geospatial community traditionally have used the ISO model, the Lineage model, to capture provenance information. In this way, we can codify this model in XML and capture the provenance information about the processes and about the sources used. But what happens if I want to capture a literal data? I don't have a specific place to put it in the Lineage ISO model. In this way, in this context, we propose the combination of ISO model with BPS standard, in the sense that ISO model allows us to describe provenance information as a succession of processes that use some specific sources, and WPS give us more variety of data source format and allows us to capture literal data information. So in the context of Miramon software, we capture all the provenance information of all the Miramon models, and that's have been documented with WPS described process documents. So the process description, the inputs or inputs, and the model syntax of all the Miramon modules have been transformed in the WPS described process documents, capturing the process description, the inputs, the outputs, and the model syntax too. This way, we have the process capture, and we have also the sources. And if the sources that can be an input or an output, and if we want to capture the specific value of a specific parameter, we can keep it as a literal data. How does it work in the Miramon architecture? So what we did is a provenance engine that generates lineage of provenance information using WPS described process documents. This provenance engine is part of GEM metadata engine, which at the same time generates the metadata archive in a REL format. This metadata archive has some dependencies with the outputs that each model generates. So this is part of the Miramon, and also the GEM interface can help us to visualize the provenance information capture and allows us to edit and modify it manually if we need it. So if this is the GEM interface, here at the top of the interface we have the name and the metadata file. Here we have on the main menu of the different options, and then there is this Lineage tab. This Lineage tab allows us to show us the lineage tree, showing the different process and the different parameters used to generate a specific data and a specific layer, because we are in a GIS context. So if we push in the top of the layer, we can read the description of the process of this layer. This is similar to the ISO statement. What the statement is in the ISO model. Then we can also add new processes or delete new processes if we want. These processes have an identifier and a process description, and then we can add also which organization ran this process and when they did it. All the processes that we add have associated some parameters, some sources specific for each process. However, we can add this process by adding or deleting or removing some sources. So we have an identifier and the purpose of its sources. Then we have the type of value, the unit, and the value of the sources. So if it's a real source, or if it's a no value, a logic data, literal data, etc. And what is more important, if it's a literal, we have the value of this data. Then we have the location of the source, and we can add if this source is an input, is an output, or is an input that can become an output too. So having a look to the XML ISO Lineage model, we can see how all the tags that we have in the ISO model can be visualized in the GEM interface with all the process and all the sources. And if we have a literal data, we can keep it. As a conclusion, so just geospatial provenance facilitates geospatial data evaluation for reuse and brings us closer to replication of a process change. The combination of WPS described process documents with ISO model provides a more complete provenance description. The Lineage tool allows us to capture provenance information automatically, and what is more important, also edit it manually if we need it. And this process is also used to generate automatically the models of help in Miramon, but it's the WPS service prototype has been developed already. That's all. Thanks.
Well, we are moving to the last two presentations. The first one by Cristiano Fugazza, researcher by the Institute of Electromagnetic Sensing of the Environment of the National Research Council of Italy. He's researching in semantic interoperability for spatial data infrastructures in the context of projects, Italian ones for RIDMARE and LTR, long-term ecological research. And he works by the institute mentioned before and focus his work on the exploitation of multilingual thesauri for annotations and discovery of spatial resource. He's a PhD in computer science, quite different from the others, geographicals and geologists, and coming from another world. We are waiting for... If there's any problem? No? Okay. If you have some question for the previous presentations, meantime, no time at the end.
Okay, should work. Thank you very much, Dolores. As the title of my presentation may suggest, this talk is about how to make fit INSPIRE metadata for the semantic web. A typical approach is finding an appropriate mapping between INSPIRE metadata and a given set of RDF schemata. This is, for instance, the approach of GeoDCAT we've been discussing this morning and this afternoon. Our approach is different. We try to focus on the workflow, for production and consumption of metadata. If you want to say another word, don't ask what INSPIRE can do for semantics, but ask what semantics can do for INSPIRE. The results I'm presenting stem from the achievements of Project Ritmare, an Italian flagship project aiming at bringing all the distinct contributions to Italian marine research under the same umbrella. Enough for presentations, let's go straight to the use case. The hero of our game is John Doe. John Doe is a researcher by Acme Research, a fictitious research institute managing geospatial resources through an INSPIRE-compliant SDI. Specifically, John Doe is the creator of dataset ABC, and he's also the custodian of all the resources made available by the SDI. Now let's take a closer look at the metadata that is annotating dataset ABC. Among the whole XML tree of ISO metadata, I focused on the two branches indicating John Doe as the creator, the author, and the custodian of these resources. Now, at some point, John Doe decides to change employer. As a consequence of this, all the metadata made available by the SDI is made inconsistent. Specifically, in dataset ABC, the author shall change because John Doe is going to maintain authorship of this dataset. So the name of the company he works for and his email address shall change. Moreover, Acme Research is going to appoint a new custodian, and so also the email address of the custodian shall change. Now, be earnest. The average system administrator is not going to apply these changes, and your metadata will remain inconsistent. Instead, with our metadata methodology, we are able to keep this metadata consistent and updated by leveraging RDF data structures. Let's see how we achieve this. This is the first part of the workflow, the production of the metadata. Since in Ritmare, we had to produce metadata according to multiple schemas. For instance, the basic INSPIRE, RNDT, which is the transposition of the Italian transposition of INSPIRE, but also SensorML version 1.0 and 2.0. Then we didn't want to have 4 different editors. Rather, we developed a meta-language encoded as an XML schema, according to which the system administrator can tailor the metadata format that he wants metadata maintainers to produce. In this template, you can also plug in external data sources. Any external data source made available as a Sparkle endpoint can in principle be plugged in. Also, you can encode in this template all the mandatory fields, multiple fields, and all this kind of stuff. Once this template is prepared, we have a JavaScript application named Edi that is able to compile this template into an HTML5 web form that helps the metadata maintainer creating the metadata in an extremely user-friendly way by transferring all the constraints expressed in the template and connecting to all data sources that are defined. Then, when metadata is created, it is sent to the Edi server that produces either the XML encoding that is desired, so that you can insert these metadata into catalogs, for instance. In our case, these are the peripheral nodes of the Ritmare infrastructure. Also, the Edi server produces an RDF counterpart to metadata. So, we can store the metadata in a triple store in the centralized node of the Ritmare infrastructure. Now let's take a look at what the template look like. XML is quite difficult to understand the meaning of every node, but as I said before, you have an XML schema to help you tailoring your metadata profile. I focused on the three important elements of the template. The first is the definition of a data source. We define a data source named the person that executes a Sparkle query to a Sparkle endpoint provided by the URL tag. In the Sparkle query, you find the magic word $search _ param that is substituted runtime by the text entered by the user. Then, when defining the different metadata elements that the metadata maintainer should provide, you can refer to this data source. And then, in the RDF out element, you can specify which are the RDF triples that shall be generated by using the data that the metadata maintainer has entered. This complexity brings to a very user-friendly application. When providing a point of contact, for instance, the user starts typing an email address, and the interface issues the Sparkle query to the remote endpoint, passing the parameter actually entered by the user, get the results, and presents them to the user. Upon selection of one of these results, another data source that is omitted for the sake of conciseness allows to autocomplete another field in the metadata, which is the name of the institution that John Doe works for, in this case, Acme Research. Also, the role that John Doe fulfills in this case is taken from a drop-down list. You cannot see it in the picture, but in principle, any SCOS thesaurus can be plugged in order to provide the drop-down lists. Finally, the triples that you saw in the previous slide with the signposts for the different metadata elements are produced and inserted into the triple store. Now you say, well, you're explaining us how good is your metadata editor, producing XML, RDF, using heterogeneous Sparkle endpoints, but in the beginning you've been talking about automatically update of metadata, of INSPIRE metadata. How can this be accomplished? It is the second part of the workflow related to the consumption of metadata. In fact, as soon as the end user discovers a resource, say dataset ABC, the RDF metadata is fetched from the triple store. The AD server then compares this metadata with the template. In the template, there are the data source definitions, and interpreting the RDF metadata according to what the template says, the remote resources on the linked open data cloud can be queried again, and the current values of all properties defined in the specific metadata profile you are working with can be fetched from the web. And this allows for having a final XML representation of INSPIRE metadata that have all elements updated, of course, to the extent that the remote data sources have been updated. Let's see how this happened. In the template, we've seen the data source person defining the URL of the Sparkle endpoint. Well, other than the RDF out element we already saw, you have the RDF in element. An outer RDF in element at the same level of the RDF out one defines the query that shall be issued to the local triple store, the one containing metadata. In this case, the query asks for all contact points. Once these contact points are retrieved, they can be further queried to the remote endpoint. So we have also the RDF-in block into the individual item, in this case the email address. We have the triples that shall be issued to the URL that is specified in the specific data source. The application compiles a federated Sparkle query that fixes half of our use case, in the sense that now the new email address of John Doe and the name of the new employer of John Doe can be updated to to its current value. But we cannot fix the second part of our use case. Why? Because the custodian information will contain the new email address of John Doe, but John Doe is not anymore the custodian of all data sets. So we need to do a trick. We create a signpost, a URI that corresponds to the people that in that moment covers the role of custodian. And we associate this URI with the URI of the specific person. You can use whatever property you want. We used RDFS-C also, but this is just a convention between your template and your triple store. So no one will ever know. Then you create a new data source for this purpose. This data source knows of this indirection step, and then can ask which is the real contact point acting as a custodian. And then you modify also the RDF-in tag accordingly. Once you compile this set of queries, you can also fix the second part of our use case, because you will be looking for the person that is currently covering the role of custodian of this information. So, resuming, I've been presenting a metadata editor that can be customized to any XML profile and linked to any data source, remote data source made available as a Sparkle endpoint. Then your metadata is translated into XML for insertion in catalogs and so on, but also as RDF. And this translation allows to keep the original metadata items updated, because the prescribed XML format, say INSPIRE or NDT, SensorML, and so on, is generated on demand and is generated on the actual values of remote data sources. You can find this software available as a free and open software on GitHub, and thank you very much for the attention.
Well, the last speaker will be Monica Pepe. She's a geologist with a PhD in physical geography. She is also a researcher by the Institute for Electromagnetic Sensing of the Environment of the National Research Council of Italy. And she has 20 years experience in remote sensing, and in the last 10 years collaborate with the SDI research group at her department, following activities regarding INSPIRE and Sensor Web enablement initiatives. Monica?
Thank you. Good afternoon. As you can see, I work with the same institution of Cristiano, and with them and with other people on the behalf of them I'm speaking. We take care not only of INSPIRE metadata, but also of other kind of metadata profiles, and particularly I'm speaking about the SensorML. And SensorMLs can be very meaningful, but it can be very painful as well, because it's very long to be compiled. And so the aim of my presentation is to show two two things. One thing is automation. With the aid of this editor you have seen in the previous presentation, which allows for computer-assisted editing of metadata, and also semantic enrichment and delegation to other sources. And on the other side, also that since this metadata is so complex and so long, there is a possibility to split the work between different actors, and so to provide some information, and so that parts can be provided from different actors in a workflow, and so involving sensor manufacturers and not only sensor owners to compile the metadata. So we can see the same architecture that which is one of our projects, but it can be seen in a little different use case, in which it is not only distributed the architecture, but also the charge of work, because the knowledge is distributed. We have the system administrators who knows everything about schemas, about XML, about profiles, and so about encoding. And so they can prepare such templates that can be used for have a valid sensor metadata. On the other side, there are sensor manufacturers that can use the metadata editor to provide all invariant information. They know their sensors, and so they can compile something that we have called the blueprint. So something that is describing the sensor characteristics, physical characteristics, and which are typical of the sensor. And after that, there is the sensor owner, which is responsible for creating the metadata at last, that he knows everything about his own system, about the maintenance, the history, what's happening, calibration events, who is responsible for the data, if anything happens on observations. So this person could take advantage of have already pre-compiled the blueprint collection, and so just concentrate on the part of metadata which is of his own interest, and but it is very important for the final users, the people looking for observations. So as we said before, we have implemented the metadata editor as a service. And so there is a server part and a client-side component. This is client-side component looks like, it's a little bit small, I think, but anyway, can be seen. And this is generated on the basis of these templates, according to the metadata schema that Cristiano showed you before. And at the moment, we have different profiles implemented, which is INSPIRE, our Italian transposition of it, and several profiles for SensorML. And also, it is under preparation the environmental monitoring facility profile. So, when you have a profile, you need your to write down the template corresponding to it, but this is the part that the system administrator knows, and he knows everything about the encoding and mandatory fields and what is needed to have a valid SML. And on the other side, this tool needs also to help you in filling out the web form, and so it can be useful to use such triple stores that, for instance, these sources that contains, for instance, thesauries. And so in the case of SensorML is when you need to declare the parameter which is observed, it is important to refer to control vocabularies, and this also allows for having in our REF store also the URI corresponding to the parameter. And not only this, if we want to help a user in compiling the SensorML, we can use this possibility to use different sources also for the auto-completion of some fields. For instance, we have created a friend of a friend structure for storing all the manufacturers, or the most common manufacturers of sensors. And so just typing the first 3 letters, you can choose the manufacturer name. And from the manufacturer name, other fields of metadata can be compiled, making use of this triple store, and so it's important help for the sensor owner to have a lot of work already done. And I have shown the XML of a template just to, but you had enough for SPARQL queries, I think. And so, but these parts are not the only invariant parts of SensorML, and so this is why we have thought of a possible involvement of sensor manufacturer who are able, with the same interface, to compile the parts which are just typical of the sensor model, and these blueprints can be collected. And so we did this as a proof of concept. We did the manufacturer work for just for proving that everything works. And so we have this this site. Unfortunately, the URL cannot be seen, but it's a SensorML prototype catalog in which you can find several blueprints for several sensor models used in marine research, and by selecting the model you have, you can start editing your SensorML metadata with these invariant parts of the SensorML already compiled. So you can focus only on the important parts of the dynamic parts of the SensorML, which are the ones in charge of a sensor owner. And so a lot of work of this metadata completion is already done, and also the parts of semantic enrichment of this SensorML metadata are stored and can be used also in a way that Cristiano has showed you before. And at the end of the day, there is also the possibility, if you have something that makes your XML file more readable, to check the quality of the metadata, the SensorML you have produced. We have here an application that is also on GitHub, as everything else, that let you have a look in a more human-readable way on one side, and a And another one which is more for RDF people like Cristiano, to understand if the quality you have reached in your metadata completion is enough for your purpose. And that's all on my side, and I think it's time for question, not only for me.
Thank you very much. Then there is time for the public, the audience. Questions, please.
Thanks. My name is Michal Met. I'm from Czech Technical University in Prague, and my question is maybe all three of you. I would like to ask about the whole concept of creating a GeoDCAT AP out of ISO metadata profile, because in my opinion, I think that ISO metadata profile is object-oriented profile, and it doesn't allow some relations that are basically allowed in RDF. And for example, the semantics, which is one of the most important things. Why are we doing RDF schemas and RDF data? So my opinion is maybe it's not the best idea to have an try to create some mapping from the simple model into the difficult one, because it's simply not possible. So I think that maybe it would be easier to create a profile which isn't binded by the ISO profile, which is object-oriented, and some relations aren't easily allowed to model there. So that's basically the question.
Actually, I didn't get exactly your question, but I've been listening to the GeoDCAT debate, and earnestly, I've been longing for an RDF translation of INSPIRE metadata for 2 years. So then GeoDCAT came, and I've been looking at it and was a little disappointed, because if you just wanted to translate your INSPIRE metadata to CCAN, then GeoDCAT is what you're looking for. But if you want to add semantics, for instance, to have a lot of URIs, for instance, if you take the point of contact I've been showing in my slides, in GeoDCAT, you cannot have it represented as 2 URIs, simply. So there is a lot of interesting stuff that you can do with our RDF representation, which is not our RDF representation. It's based on the OWL model of the C211 data models made by Simon Cox in 2009, I believe. And secondly, I don't think that we are moving from a very simple model to a very complex model for no particular purpose. Because actually, when you are associating a data value, a string, an email address in a contact point to a URI, you are doing a lot more. Because, for instance, if you want to translate this metadata into another schema that is not an INSPIRE profile, it may be a SensorML, it may be any other schema, you can take advantage of this URI, because connected to that URI, you can have a lot of information, not just the email address. So this is semantic lift. It's what we should aim at when making a semantics-aware translation of a given metadata. Okay, we move from something that is less complex to something that is more complex, but we do it because we know the advantages of doing it. Does this reply to your question or not?
Yes, I think that I understand what you told me, that we are using something more complex, but my question is wasn't meant this way exactly, because we are trying to convert something less complex into something more complex. So maybe it would be easier to do it the opposite way, you know. I think that you lose information because you're trying to convert some relations from the source that doesn't allow it. Yeah.
When you're using the metadata editor, you are working with something that is more complex than the result. Because when you select the email address of the point of contact, you actually are selecting a URI. Then, if you want to produce INSPIRE metadata, you're just interested in the email address. But what you are creating is more complex than what you are trying to achieve.
Maybe you do not lose too many information, but you lose a lot of potentials. For instance, in our case, in Italy, when you compile our INSPIRE profile, you have something like 32 fields to be filled in. And using triple search as sources, data sources, we have reduced this to 6. So, and also you have the potential of the automatic update of metadata. So I don't think it's just a point of compliance, but it's a point of opportunity also going to open and linked data world.
Hi, this is Paul from GeoDCAT. So when I look at the open data world, and I see quite some products out there like CCAN and Socorta, they use DCAT on a quite flat mode. They don't use the semantic capabilities of DCAT themselves. So I was wondering, I think the void ontology is actually far more interesting from a linked data perspective to describe data sets. Do you have any experiences there?
So far, we didn't try to work with this schema because we didn't have the opportunity and the necessity of doing it. But I don't think that it is very difficult. It is, if you have void information available as a Sparkle endpoint, then you can easily plug in and do interesting stuff with our editor. Maybe it will not be an editor of metadata for datasets, but maybe an editor for groups, for clusters of datasets, for more interesting stuff under this point of view. Yes, this.
More questions? No? Well, regarding the problem of interoperability at Lineage element, I would ask if there is some proposal at the maintenance and group regarding to provide some template or some recommendations in order to use these words or these sentences or these elements to describe the lineage, because it is mandatory for one side, but the other side I could put anything useless. No?
Well, I think the way is not to do any recommendation. I think the only way is to use standards. If we could have, you know, I made this map using this standard, which means restitution, digitalization with this accuracy, or that some kind of the same, you know, in the 3D models that they have LOD1, LOD2, LOD3, so they don't have to explain anything. They just say that, and everybody understands what are they doing. So if it could be some kind of a standard that when you are speaking about quality, you say quality A, and quality A means this, and that, it could be good, but there are not standards in that way yet. is beginning to be a standard, for example, for very recently, about how to measure a flat. Because if you ask how many square meters it has, everybody answers in a different way.
Yeah.
And now they just answer, there is a new standard for that. So you don't have to explain how did you measure it. You say it is following this standard. Eventually it will happen in mapping and cartography, I hope. It's not like, no, I did the orthophoto in my way. No, in my way, no. There are not many ways. Let's go to fix 3, 4, 5, 15 ways, and then you choose how are you doing it. It's my opinion.
Okay, it's not the process of the work done by the maintenance group, no? It's not to provide some code list or something like that, just to make more clear what you have done with your data. More questions, suggestions, proposal? I think the conclusion is that this group of speakers can detect several gaps, errors, mistakes, or whatever you can say about the profiles of metadata, the INSPIRE, the standards, ISO 9000, and they suggest, as Alejandro has said now and before the other speakers, with RDF, with semantics, there are a lot of possibilities, but we need to use in a similar way. I think it's not sense to use the readmare with a specific way, another project, another site, and everybody use semantics, but everybody in different way. Interoperability is less and less every day. Well, I hope we could take benefit of all these ideas, and I expect to see you again in the next conference of INSPIRE. Okay? Thank you very much.